Okay, boys and girls, this is our review for Chapter 1 test. So the first one, our first problem says, draw a horizontal line representing odd numbers between 12 and 22. So in order to, what you would need to do first is to draw a horizontal number line. So to draw a horizontal number line, just draw a line going across. Vertical is up and down. So I'm going to draw that. I notice that it's numbers between 12 and 22, so I'm going to write 12 and go up to 22. 16, 17, all the way up to 22, 19, 20. Oh, ran a little room there. Let me just erase that. Okay, 21 and 22. Sorry, it's a little squished. Okay, so it says between 12 and 22, so I need 12 and 22 there, but it only says odds. So now what I'm going to do is I'm going to color in all the ones that are odd. So 13's odd, 14's odd, 15's odd, 17's odd, 19's odd, and 21 is odd. For the rest of them, you just leave them as the little hash marks. Next, draw a vertical line. So now we're going to draw a vertical line. So vertical line means up and down. And it says fractions between 2 and 3. So I'm going to write 2 here. So we go on, and we're going up by 1/3. So it's 2, 2 1/3. I'm going to write over here 2 2/3. And finally we have 3 over here. So what we need is between 2 and 3. So we're going to again fill in. So we fill in 2 1/3. 2 2/3, but I'm not going to fill in 2 or 3 because it says between 2 and 3. Next, what we have here is write the correct inequality. It should just say write the correct. That's a typo. It should write the you should write in either less than or greater than or equal to. So it says this first one is 3.5 and 3.5. So what you would need to do is either make the half into a decimal or the 0.5 into a fraction. So what I like to do is I'm just going to make the half into a decimal. And so 1/2 equals blank over 10. I did 2 times 5 is 10, so 1 times 5 is 5. So that's 5/10. So it's 3.5 is the 3.5 there. So they are equal. So I'm going to write equal. Then we have 45 hundredths or 4/5. So if I write 4/5 and make that into a decimal, I'm going to make it times 2. So it's 8/10. So 0.5 or 8/10. Now, that's an 8, sorry. Now what you need to remember is this. Is that you can't compare a decimal until you have the same number of places after the decimal. So what I would do is just add a 0 here. And I look at it as either 45 or 80. So 80 is bigger, so 4/5 is greater. 9/10 or that's 900 thousandths. So 9/10 or 900 thousandths are going to be equal because 9/10 is 0.9. And then I would add zeros to make them even, and then they're equal. Or not even, but the same amount of digits after the decimal. Same one with here, I'd add a 0, so that's going to be equal. We have 8/10, so 8/10 looks like this, and as a decimal it's 0.8, and I'm going to add a 0 there. So it's 80 versus 0.79, so 80 or 79, 80 is bigger. Last one, I'm going to add a 0. And if I add a 0 there, it's 760 versus 758. 760 is bigger, so that is greater than. Okay, next page. So the next page is write each number as a product of its prime factors. So we're going to make a factor tree. So let me just make this a little bigger. Okay, so 70, I can do 7 times 10. I'm going to circle the 7. And 10 is 2 times 5. Circle them because they're both prime. So it's 2 times 5 times 7. Remember, make them in numerical order. 500, I could do 10 times 50. 10 is 2 times 5. I'm going to circle them. 50 is 5 times 10. Circle the 5. And 10 is 2 times 5. Now this one, I look at the 2's, I see 1, 2, so it's 2 squared, times 1, 2, 3, 3 5s, so it's 5 cubed. So it's 2 squared to 5 cubed. Okay, next, what we're going to do is GCF and LCM of each set. So the first one, we're going to do the GCF. So if I do the GCF of these, I'm just going to use a division ladder. It's a little bit easier. I know 4 goes into them. So 24 divided by 4 is 6. 32 divided by 4 is 8. 48 divided by 4 is 12. I notice I could divide again 2. So 6 divided by 2 is 3. 8 divided by 2 is 4. 12 divided by 2 is 6. Nothing else can go into the bottom numbers. So it's 4 times 2. So the GCF would be 8. Now, let me just erase these. Now, LCM for these. Oops. Let me redo that. Okay. So the LCM for these, what you would need to do is make a factor tree for each. So 24, I could do 4 times 6, and this would be 2 times 2, 2 times 3. So that is, let me just move this up, would be 2 cubed times 3. 32, I could do 4 times 8. That's 2 times 2. And 8, I'm going to do real fast, is 2 times 2 times 2. Sorry about that. So that's 1, 2, 3, 4, 5. So it's 2 to the 5th. 48, I could do 4 times 12. 4 is 2 times 2. 12 is 4 times 3. And that is 2 times 2 for the 4. So there's 2 to the 4th times 3. So again, remember, we look for the biggest ones. So the 2's, it's 2 to the 5th is the biggest. I have a 3 and a 3 over here. No 3 there, so I have to take 1, so it's 3. So 2 to the 5th is 32. 32 times 3 is 96. So the answer for LCM for that one is 96. Okay. Oops. At the bottom, we have 12 and 25. So the GCF of those is actually pretty easy because it's only 1. So GCF is 1. And the LCM, 12 is 6 times 2, 3 times 2. So for here, I have 2 squared times 3. For 25, it's 5 times 5, which is 5 squared. So technically, you need to use all of these numbers. So it's 2 squared, which is 4 times 3. 4 times 3 is 12, times 25. So it's 12 times 25, and if you need to write it out, write it out. The answer is 300 for the LCM. Okay, next page. Oops, I just missed it. Okay, next page, we don't need to do this one. This won't be on the test, but I'm going to show you how to do it anyway. So the square root of 169 is 13. So that means 13 squared equals 169. Then what is the value of 130 squared? So if 130 squared, it wants to know the value. Well, to get to there, you always say, how do you get there? Well, how do I get there is I use 10 squared. So I need to add a 10 squared. Well, 10 squared is 10 times 10, right? So 10 times 10 is 100. So 100 times 169 is, just add the zeros, is 16,900. Don't worry about that one. That one's not going to be on the test. Okay, next one. PEMDAS, we work inside out. So I have inside, I have a couple of parentheses. So I have 7 squared. So it's 49 times 4, because you have to use, and remember, PEMDAS, let me just write it. It's parentheses, exponents, multiplication, division come on the same line, and then addition and subtraction. So I'm working on the parentheses. Inside the parentheses, I see a exponent. So I got to do that exponent first. Plus, I see an exponent. 3 times 3 is 9, minus 7, and cubed. Next, keep working on the parentheses. So 49, I have 49 times 4, which is 196, plus 2. 9 minus 7 is 2, and that's cubed. So I have 196 plus 2 cubed is 2 times 2 times 2, which is 8. So that answer is 204 when you add it up. Okay. Next one you don't have to do. It's not going to be on the test, but find two consecutive numbers whose squares differ by 25. I'll show you how to do this. So it's kind of guess and check. So what it means is this: two consecutive numbers, like 9 squared and 10 squared. So 9 squared is 81, 10 squared is 100. So the difference means when you subtract them. So 100 minus 81 is 19, so that doesn't work. So keep going until you get it. So you could go up 10 squared and 11 squared and so forth, but the answer is going to be 12 squared and 13 squared. So that's 144, that's 169, and when you subtract them, you're going to get 25. All right, so this one. Riley's packing 144 pencils. 120 files, 108 notebooks, equally into as many boxes as possible. So what you need to do for this is we want to find the greatest number of boxes that Riley and could pack the items into. So we're going to find the GCF of this. So I'm going to do 144, 120, and 108 and do a division ladder. And if I do a division ladder, I could start with, well, I'm going to tell you right away, I know 12 goes into them. So 12 into 144 is 12, 12, that's 10, 12 into 108 goes 9. So the greatest common factor is 12. So the greatest number of boxes is going to be 12. So find the number of pencils and files in each box. It's going to be 12, 10, and 9. So whatever's left over here, that's what's going to be in every single box. So there's going to be 12 pencils, 10 files, and 9 notebooks. Okay? So when I saw greatest number, I knew right away it's going to be GCF. Imelda, Susan, and Claire are driving go-karts on a track. Imelda takes 14 minutes. Susan takes 18, Claire takes 10 to drive 1 lap. Suppose all of them start together at a point and drive at their same speeds. This is similar to one we had for homework. About how many minutes would all 3 meet again? So it's the least common multiple where they're going to meet. So we write 14, 18, and 10. This is 2 times 7. This is 2 times 9, which is 3 times 3. And 10, it's easy, is 2 times 5. So let me just move this up a little bit. So we take, it's 2 times 7. This is 2 times 3 squared. This is 10 is going to be 2 times 5. So when I look at this, I take the biggest of each. So I got a 2 times, I only have 1 3 squared, so I need to use it, times I needed the 5, and I need the 7 because you have to use all the numbers. Remember all the numbers, but only the biggest of each. So now it's 2 times 3 squared is 9, so that's 18, times 5, times 7. And then what I'm going to do is do 18 times 5. So 18 times 5 is 90. That's 90. 90 times 7 is 630 is going to be the answer. All right, a couple more. 34. So 34 is how many squares with sides that are 6 inches long are needed to cover a square with a side length of 30 inches without overlapping. So I'm going to draw a quick picture. Okay, so a side is 30, and the key is squares. So here's a square, 6. Okay, so you got to figure out how many go in here. Well, these all have sizes of 6. So I have 1, 2, 3, 4, 5 go here, and then this is going to be 6. So going up, I got, it's going to be basically, because it's a square, I didn't draw it, I kind of messed up, so I didn't draw it perfectly. So let's see, 1, 2, 3, 4, 5, right there. So there's going to be 5 of them going up also. I'm sorry, let me erase it and do a little better job. Okay, so let's do this again. Oop, I don't know why it does that. Okay, so here, 2, 3, 4, 5, 2, 3, 4, 5. Okay, that's a little better. So each one of these, the side for this is going to be 30. This side is 30. Each one of these is 6 by 6. So that's 6, 6, 6, 6, and 6. That equals 30. And then going up, 6, 6, 6, 6, and 6. So that's 30. So when we do this, if you have 5 going here and 5 going up here, 5 times 5 is 25. So the answer is going to be 25. Okay, last one. A wooden crate is a cube. So you gotta remember it's a cube. And a cube looks like this. Similar. It's not a perfect cube, but anyway, each length is 18. So a cube has length, width, and height as the same. So 18 inches. The crate contains tiny plastic cubes with edges of 3. So we have little tiny ones in there with 3 inches. How many can fit inside the crate? So what you need to do is this. So we got to figure out how many go across, how many go this way, and how many go up. Well, you have to divide 3 into 18. So 6 go this way, 6 go this way, and then 6 are going to go up. So it's 6 cubed, or 6 times 6 times 6. And if you do 6 cubed, you're going to get 216. So the answer is 216.